All right, for Math 4, worksheet 1B, this is the second half, picking up at number 4. Here we're talking about x cubed, and if we're going to draw that, we're going to have to remember, it's almost like you're drawing a table here, and if x is 0, then x cubed is 0. If x is 1, then 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. So it goes out of sight pretty quickly. But we still should be able to get our dots in there. 2 goes up to 8. 1, 2, 3, 4, 5, 6, 7, 8. One above. Now, one thing that the cubic function does is instead of doing it on both sides, on the left side and the right side, on the left side, it actually swings down. So instead of going up over here, we're going down over here. And then we're going to go one off the edge down there, just like we went off one off the edge. So the function is going to look something like this. So the function will look something like that. It's like it's a stretched out parabola, but the left side swings down instead of up. All right. So now we're going to that 1, 1, 2, 8, and over 1, down 1, over 2, down 8. Okay, there is our graph to look at. The domain, even though it looks like it's going up and down pretty fast, it still moves left and right, and it will still continue to do so forever. The range will also continue to move up and down forever. The x-intercept and the y-intercept is going to be 0, 0 for our parent function. Now, I will say that after we get through playing with this, we're going to start looking at transformations, how we can translate or reflect or rotate, all that good stuff. Let's see now, and then that's not what I wanted. All right. All right, we'll start down here. Do something like that. All right, relative local min. Well, there's nothing relative about this graph at all. It's absolute down and absolute up. And so we're going to say that the relatives have nothing. The absolute minimum is going to be negative infinity. The absolute maximum is going to be positive infinity. And then looking at things like it, well, when you think about it, the whole thing is increasing. Oops, that's got to move over 1. Okay, so it's increasing the whole way. At no point is it decreasing. So that's going to be from negative to positive infinity, nothing decreasing. And we've encountered this before. From the origin, everything on the left side is negative below the x-axis. Everything on the right side is above. And 0, 0 itself does not count. So negative is going to be negative infinity to 0, parenthesis. Positive is going to be 0, parenthesis, to positive infinity. And the endpoint behavior, as x approaches negative infinity, let's see, that's going left, then y is going down as well. And as x approaches positive infinity, y also is going up. That's number 4. Now we'll start playing with the square root function. This is the sound of me squirting the cat to get her off the sink. All right. Now, remember how when we did parabolas, we'd do a spot? Now let's change colors here so we can see what we're doing. All right. Now, in this case, the square root function is going sideways. So instead of going over and up, this time I'm going up and over. 1 up, 1 over, 2 up, 4 over, and then 3 up will go 2, 4, 6, 7, 8, 9 over. And so our square root function will look something like that. Now, remember how when you try and stick a negative number inside a square root, your calculator laughs at you? That's because you can't have the square root of a negative number. So, there is no bottom half of this because in this case, y is negative. You cannot ever put a number in for x and have it turn out, the answer turn out to be negative. So your square root curve is pretty much from the origin up. Now, obviously, we're going to have some translations, and that's going to, tweak that a little bit. But in any case, that is what your square root function should look like. And it is pretty much a variation on the on the parabola. 2, 1, 2, 3, 4. And so we'll just do that like that. All right, our domain is going to start from 0, clearly on 0, and go to the positive infinity. Likewise, the range will start where y is 0 and go to positive infinity. The x-intercept, the only one it has, is the origin, and likewise the y-intercept. Right, that, and that. Now, relative local min and absolute min, they're actually one and the same. They're the origin. But when it comes to a maximum, there's no local max because it keeps on going on forever. And so the absolute max is going to be infinity. All right, when we start talking about increasing and decreasing, well, I guess when you think about it, there's no point of this where it decreases. It will always keep going up. So from the origin where it starts until infinity, it's going to keep going up, and there is no decreasing. And there is no negative because it's all, well, there is one spot. It starts from 0, but 0 is not a part of the answer because 0 is not considered positive, but it does go on to infinity. And for the endpoint behavior, on the left side, as x approaches, well, it's not approaching negative infinity, is it? It's stopping at 0. So as x approaches 0, well, so does y. But on the other end, as x approaches positive infinity, it's going on forever, and so is y. That's number 5. And last but not least, 3 to the x, which would be the same as that. Now, this might be where, just to give us an idea of where this is going. If I stick a 0, 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2, 3 squared is 9. And 3 to the third is 27. So that gives you an idea that it will start from here, 1 and 3, 2, and 9, which is basically 2 units up there. Now, something else happens along the way, because as if I stick a negative in there, what if x is -1? Wait a minute now. What is 3 to the -1? Well, that is like 1/3. What is 3 to the -2? That is like 1/3 squared, which is 1/9. You can see that as we keep going with this, my fractions are getting smaller and smaller and closer to 0. Now the question remains, if I keep going in this pattern, will I ever reach 0? And the answer is no. It will keep getting smaller and smaller. I wish, and I may have to save the story of the football. Oh, that is a horrible line. Let's try that again. It's going to come here and do that. Just like that. And so that's going to be the curve of it. Never touches 0, but shoots out of sight pretty quickly once it crosses 0, 1. So let's see how we answer the rest of these questions. There, and 1, 2, 3, and there. And so we're going to start along here and sweep up there, and sweep up that way. All right, the domain, when you think about it, and this keeps moving to the right, so it's going to go both directions. But the range, it's never going to get below 0. As a matter of fact, it's never going to get to 0. And so the range is always going to be just this side of 0, all the way up to infinity. The x-intercepts, there are none. The y-intercept, there's only one at 0, 1. And let's look at the next set. There, there, there. Okay. Now, this one is going to be a hard one to answer as far as minimums. There's no such thing as a local minimum. And the only way that we can answer the absolute minimum is that y is greater than 0. Because your absolute minimum is kind of like infinity, but infinitely close to 0. So that's the best way that we can list it and still be accurate. Now, relative max, well, there is no, hump along the way. It just shoots out of sight. The absolute maximum is going to be infinity. Now, the last set here, bang, bang, boom. Okay. It's increasing the whole way. There is no part of it that's decreasing. There's no part of it that's negative. All of it is positive. As a matter of fact, none of it touches 0. So it is positive, the whole shebang. Now, endpoints. As x approaches negative infinity, which it does, y is approaching 0. And never quite reaches it, but it's approaching it, kind of like infinity. And likewise, on the other end, as x approaches positive infinity, y is also reaching for positive infinity. And so that, I believe, we got one more, absolute value. We got one more. Yeah, we just got one more. Okay. Absolute value. This one is an interesting one to draw. As a parent function, it starts at the origin and it goes diagonally with a slope of 1 that way, and then it goes diagonally in this direction with a slope of -1. And so, it goes in half that way. Now, when we start playing games with it as far as transformations, it is possible to stretch it and flatten it like you do a parabola. It is possible to shift it up, down, left, right. It's also possible to flip it. Now, the fun part is that when they want to flip it on the y-axis, sometimes you can't tell because it looks just the same before and after. All right, so we have, I'm just going to do that and that. Domain goes forever in both directions. The range stops at 0 but goes positive infinity forever. The x and the y intercepts are both at the origin. Okay. Now, as far as a minimum, there is a minimum here at 0, 0, which serves as both a relative and an absolute minimum. But when you start asking about maximums, y, goes forever in both directions. So there are no bumps, no temporary mountains, but it does go forever in the positive direction. And increasing and decreasing, we have a little bit of both. So it is decreasing here and increasing there. And we're talking about from negative infinity to 0 to positive infinity. Again, with decreasing, increasing, negative and positive, you're watching what y is doing, but you're writing what x is doing. And so x is increasing from 0 to positive infinity, and it's decreasing from negative infinity up to 0. And again, at that point at the bottom, it's neither going up nor down, so 0 doesn't count either way. There are no brackets, just parentheses. Now, negative, nobody is below the x-axis. Everybody is above it, but there is a break at 0 because at 0, 0, it is not positive. It is not negative. It is neither one. All right, endpoint behavior. As x approaches negative infinity, y is going up. As x approaches positive infinity, y is still going up. And that is what your endpoint behaviors should look like there. And that is the end of it.